Hello, I'm Daniel Temment, and I will present you today Bionics. Maybe at the beginning, a few things about myself. My background in education is mathematical physics, also informatics and music. So my work areas are programming and informatics, then artificial intelligence, also machine learning, then optimization algorithms connected with usually smart factories. Perhaps you hear about Industry 4.0, then health and music. And as you can see, almost all my fields are somehow connected with bionics. Here you can see also my email, so don't be hesitated to contact me if you want about anything what I'm saying or I will say today. And maybe at the beginning something what is very interesting for me, it is, I call it intelligence of the nature. Since I'm a physicist, I'm very interested also in black holes or cosmos and generally. So even today we don't know exactly what is happening inside the cosmos. Also, if we look at and observe the macro nature around us, we basically don't know how it is working so well, what are all the processes in the nature. Then also little smaller things like, for example, here butterfly. The wings of butterfly are so interesting, and we basically don't know where's coming this intelligence in the nature from to build such a great things. And at the end we'll come to cells and also DNA inside it. And probably, as you know, there are millions of informations stored inside these molecules, and we can say there are basically not three-dimensional. This is some kind of 4 or even 5-dimensional informations. It tells all our cells how to work and when how to work. So we could say that we don't know maybe not more than a few percentage of this. And we can easily say that the nature, our planet, is the smartest environment that would ever exist, because it just takes care of itself, it renews itself, adapts, and throws nothing away. So we can only admire it and learn of it. Maybe some starting points of bionics. There are a few steps how bionics works, and the first steps is usually that we just observe or explore some kind of natural processes. We are usually focused on smaller processes or smaller part of the nature, which we call usually biological systems. And then in the second step, we try to analyze this process or this biological system, and we are at this step we usually don't ask why it is working so, but just how, because through the evolution basically all these natural processes are optimized so well that we believe that it works very good. And at this last step, we usually try to connect these biological systems or processes with our environment, usually with industrial environment, logistic, production, or transport or traffic. For example, exactly this so-called ants, bats, which are very good optimized in nature, is used in all these fields that I listed. Maybe would be the best if I tell you the concrete problem which I met during our conference in Ptuj in year 2017. And it was the problem for how to build a family car with very specific characteristics, abilities, uh, which this problem was a problem for scientists. It was an older man who represent us these four characteristics. The first two characteristics which are basically opposite is that the car should be spacious, so the shape should be square, and but on the other hand, it should have very small air resistance. So you can see that it is really very interesting, these two specifications. And the second pair of specifications are also somehow opposite, because the car should be safe on one hand, and on the other hand should have a low mass. We know that a safe car is usually connected with a lot of material, so it is not so easy to establish such a two specifications. And the man took this bionic approach, and the first problem solved with this fish. This fish is called boxfish and lives since dinosaurs times, and it is very small fish. Already the name boxfish tells us that this fish has the shape of a square, but the fish is very small, because also very small and also very fast, because of the tail, who is very good optimized, and but not the key specification of this fish, why it is so good, is that the resistance in the water is very small. So after customizations of the shape of the fish gives us the shape of the car, which is spacious, and also on the other hand has a very low air resistance. Also, the second pair of problems he solved by bionic approach, and in this case he took dinosaur skeleton, as you can see, and you can see also that the upper shape of this skeleton is very similar to the car, and he built the skeleton of the car from this, on basis of this skeleton, and at the end it comes out that this kind of construction is very safe with a very low mass. So both problems, or pair of the problems, he solved by bionic approach. Besides the automotive, there are also another fields when we can use bionic approach. For example, you can use DNA and pads, then birds, for different optimization algorithms. Then also in design, you can see the plant cells we can use for internal design. Also in architecture, the bionic approach is used. For example, the termites are building these structures, and they are used in the buildings using the strands. Also the process of heating and ventilations is optimized very good. And also in the textile industry, maybe the most known implementation from bionics is the hedgehog used in shoes and so on. These are just a few of possible implementation and usage of bionic approach. But generally, here you can see that basically human is by the design and production is we are using a lot of material and energy and very, very small part here, as you can see, of information. But on the other hand, the nature doesn't have so lot material and energy and so it has to be very smart. Today, if we want to be very or we don't want to use so much energy and even not so much material, so we have to work more more than nature and less than we are doing that today in our production. Uh, so here are some subjects. When you are studying the bionics, your field of knowledge should be very wide, and as you can see here, you will know a lot different areas from chemistry, mechatronics, mechanics, economy, then materials, also electricity and business and foreign languages. So is also the areas of employment of our graduates is very wide. We can find them in health, environment, mechanics, informatics, robotics, and also biochemistry. So at the end, I would like to introduce you to Dave Offand, and I was hoping that he would introduce himself, but he's really busy these days. Actually, he graduated from us a few years ago, and already in this time he participated with me in some seminar papers and also in diploma work. But today he is the CEO of the company Seat Lab, where I also work. We built this company together. The headquarters are in Graz, in Austria, and our company is today working with really, really great companies like Samsung, Suntory, B. Braun, Roche, and many others. We are also cooperating with many institutions like Graz Technical University, then Human Technologies, Styria Medical Faculty in Graz, and also in Slovenia, here in Maribor. And also we are connected in many projects regarding space tech, health, smart environments, and so on. He is working more on fields like sensorics, electronics, health, especially in last years, and I am responsible for software development, mathematics, usage of artificial intelligence and machine learning. So, if you will come to our school, this may be also your story in a few years, so I hope to hear from you and see you in September or October. So for now, thank you for your attention and all the best. Thank you.